Today, I'd like to talk to you about energy education, and specifically, I'd like to talk about daily energy use and carbon emissions. Do you know the answers to these questions? For example, how many miles per gallon does your car get? Well, you probably know that. But how many kilowatt hours per day does your house get? How much energy do you use, for example, if you have natural gas to heat your house compared to the energy used for the electricity? What's the average energy used by a person in the US, and how does your energy use compare to that? And finally, how can I compare all these different energy uses if they all have different units? So when we try and communicate, but we all speak in different languages, the way that we accomplish that is that we translate them into the language we know. Similarly, if we have all these different energy units, what we have to do is translate them into something that we know. Well, let's think about something we know in terms of energy, which is how much food we eat every day, and that's about 2,000 calories of energy that we consume every day. So the first question is, how many light bulbs, how many 100-watt light bulbs could you run with that energy? And the answer is about one light bulb. And so that 2,000 calories is about equal to 1/100 light bulb running continuously. So think about all these different energy units and ways that we consume energy. And if we were to put them, for example, on the basis of kilowatt hours, then we could compare them in the same language. But we really can't say that we know what a kilowatt hour is. And so what I think we can do is to say, okay, let's say that 2,000 calories is equal to 1D, one daily energy unit. And then we can look at all these other energy units on that basis. And similarly, we can do that for carbon emissions because 2,000 calories results in each person emitting about 2 pounds of CO2 per day. Let's call that 1C. So now when you look at this, your 1D of energy to run you, it takes about 13D of energy to run your home in terms of electricity. A gallon of gasoline has about 15D. And the food that comes to your table, those 2,000 calories, it takes about 15D to get there. If we look at all the energy used in the US and divide by the number of people, that's about 102D. Let's say you put solar panels on your roof. Well, they produce about 0.56D depending on where you live in the US. And so if you were to have 13D of electricity, well, you need about 23 solar panels. If you were going to drive 18 miles in an electric car, that might use 2D, and therefore you need about 3 or 4 panels to power that car to go 18 miles. What about if you drive 13,500 miles a year, which is the American average, or 37 miles per day? Well, your car, the average car in the US, gets about 25 miles per gallon, and so it uses 21D and emits 14C of carbon. A Prius, which gets about twice the mileage, only uses 10C and therefore emits only 7C. But when you look at, say, a Tesla, the energy that was used to make that electricity is about 12D, but only about 5C of carbon emissions results. So we can reduce our carbon emissions by using electric cars, but perhaps not as much as you think. For housing, if you heat your house with an old natural gas or oil or electric baseboard heating, you're using anywhere from 20 to 40D in fossil fuel energy, that's that FF subscript, whereas you need about 12D if you used a modern heat pump, and that would only emit about 5C using electricity from the grid. The food that you eat every day and the electricity you consume, it's about 53D and an additional 5D without carbon. Overall in the US, we consume about 102D. Where we want to get to is about 5D of fossil fuel energy and maybe 20D overall. We obviously have a long way to go to get there. If you'd like more information about energy use D and these comparisons, go to the website shown there.